Let's define a chemical bond. A chemical bond is going to be the balanced electrical forces of attraction and repulsion between atoms. This attraction and repulsion is going to be between the electrons and the protons. The electrons of one atom are going to be attracted to the protons of another atom. At the same time, the electrons in one atom are going to be repelled by the electrons in another atom. So we have a delicate balance here between the attractions and repulsions. A chemical bond is going to form when the attractions outweigh or are greater than the repulsions between the electrons. This diagram gives us a pretty good representation of what's happening at the atomic level with the energy and the repulsions that are taking place. This y-axis represents the amount of energy associated with the attractions between the atoms. In this case, the negative part down here, below zero, would represent strong attractions. The positive part up here would represent strong repulsions. The x-axis is representing the distance between the atoms. And here you see internuclear distance. So we're going to start off on the right-hand side of the graph here. And notice that these two atoms are very far apart. In a sense, there's very little interaction between them because of their distance, and we can see that based on the fact that our graph is measuring close to zero for our energy. As those atoms get closer together, as we move from right to left, we'll notice that they're getting closer. So here they're represented as being closer, and we also have the energy starting to drop. We've got the attraction between the protons of one atom and the electrons of another atom starting to take place, and bond formation beginning to occur. That's why we get the corresponding drop in energy. Whenever we form a bond, our energy is going to get lower. Eventually, we reach a certain point where our bond essentially has formed. Notice here that the two atoms, their electron clouds have overlapped, and now the bond can form. At this point, we've got the lowest amount of energy. They also are at what we would consider to be the ideal distance. If you notice on this graph, if we get these atoms even closer, so notice here they're squished a little bit closer together. That means their electron clouds are forced to overlap even more so, that our energy has started to rise again. And that's because the electrons are getting too close to each other. The protons are getting too close to each other. And what's happening is our repulsions are building up and building up. The closer they get, the higher that repulsion is going to get. And actually it's going to want to push those atoms further apart. That's why this area right here is representing the ideal distance. That distance of 74, what we call picometers, is the ideal distance between these two atoms. It also represents that we have lowered our energy by 436 kilojoules. That's a pretty significant amount. So we have, in this case, formed our bond, which gives us a lower energy state and allows the electron clouds to overlap, and in this case, for the electrons to be shared between the two atoms.